Okay, good morning, everybody. Welcome to Northeastern University. For those of you who are not from here, for those of you who are, thanks for joining us this morning. This is being live fed on the web, just so that everyone knows. So hello to everyone on the web. And we're very excited to introduce you and introduce the new CLIC Center, which is the Center for Law, Innovation, and Creativity here at the Law School, which is one of the co-sponsors of this conference called Connected Futures, Next Generation Questions for a Just World. So I'm Professor Jessica Silby, and together with my colleague Andrea Matwishin, over there we direct the new Center for Law, Innovation, and Creativity. And this is its inaugural conference, made possible, I should say, by Professor Susan Montgomery, who's also at the law school and joint with the business school. CLIC's mission is to combine the study of innovation and creativity with the study of network regulation, both legal and normative. So by networks, we could mean human networks, institutions, and collaborations, sort of old-fashioned networks. We could also mean the industrial and digital networks of this new century: internet, satellite, pipes, water, radio. We at the law school teach intellectual properties that can facilitate or choke these networks. We also teach, for example, about information security and privacy that manage these networks, as well as labor relations and securities and business associations, environmental law, First Amendment law, all concerns about regulation of these networks. So CLIC is a research and a teaching and an advocacy center for the law students who will work alongside the graduate students and the undergraduate students in this university. So alongside computer scientists and mechanical engineers, musicologists, for example, architects, social scientists, journalists, historians, we are together going to explore the nature of these evolving networks and their effects on the communities and peoples and the ways to navigate them. Because we are a law school, we are particularly interested in law's promise of transparency, fairness, and equal dignity. So we will bring that focus to the regulation and the building of those networks in the future. So as you can tell, CLIC is going to be deeply interdisciplinary, and this conference demonstrates that interdisciplinarity. Throughout the day, we are going to be joined by folks from computer science, from School of Social Science and the Humanities, from the business school. And so I have some thanks in that way to give out. So first, the Humanities Center is sponsoring our keynote speaker, Sarah Zhang, who is both a lawyer and a journalist. She will be speaking at the lunchtime hour between 12:30 and 2 about her work. The College of Computer and Information Science is also a sponsor of this conference, and we will hear from its dean, Carla Broadley, who will introduce our keynote speaker. We're also sponsored by the College of Social Science and the Humanities, and its dean, Uda Poiger, will this afternoon introduce the fourth panel today about energy networks. Within the College of Social Science and the Humanities, we are also sponsored by the Global Resilience Institute, and its director, Jenny Stevens, is here to be on the fourth panel as well. We are sponsored as well by the College of Art and Media and Design, which is affectionately called CAMD on this campus. And its dean, Elizabeth Hudson, will introduce one of the panels, the second panel today, led by her faculty colleague, Amanda Lawrence, an architect professor here. And that panel will be about copyright and urban development. So there's more. The DeMoore McKim School of Business and the IP Innovation Connection are sponsoring this conference too. And as I said, Susan Montgomery, who runs the IP Innovation Connection for the past 5 years, was the genesis of this conference, so we have her to thank for it. She's, as I said, jointly appointed in the law school and the business school and is trained in art and design as well. So interdisciplinary runs in her blood, and we are very grateful for her guidance on putting this conference together. Finally, we have to thank the law school and Dean Jeremy Paul. He will close out the conference today. The law school has been the impetus behind CLIC being generated, behind bringing Andrea and me to this school to join its community. And I have to say that its law school staff and its students, many of whom you will see here today, are both supportive and insightful. They are eager and they are fun. And I hope the interdisciplinarity and interest that this conference brings is as representative of the ingenuity that they will bring to the study and practice of law. Also, I must thank Jessica Lipson, who's the event manager here, at Northeastern, and Deborah Feldman, who is the law school's marketing genius. We are grateful to both of them for helping with this. So 4 panels today, amazing panels with keynote Sarah Jong. Thanks to the faculty members who developed and will moderate those panels. Rashmi Dayal Chan, Lee Breckenridge is here, Amanda Lawrence, and Andrea Matwishin. The panels are going to be about digital body parts, the first panel. The second one about architecture, copyright, and urban landscape. The third will be about labor markets and algorithmic discrimination. And the fourth will be about energy networks. So it's going to be a far-reaching conversation all about the connectivity of networks and the digitization of everyday life. And before we start that conversation, I'd like to introduce the Dean of Northeastern University, Jim Beam, who will say a few words of welcome.
Thanks, Jessica. Thanks all for being here today. This is really an exciting time for the entire university. As you can imagine, in any university with law school, there's been a lot of discussion over the last several years about what law schools will be moving forward. Coming through the last recession, there was a substantial change in the environment and business model of law schools. And throughout those discussions, everyone in the senior leadership of the university was, I think, pleasantly surprised by the enthusiasm of the other deans and the other disciplines about the criticality of legal thought and legal collaboration in everything they were going to need to do to be successful in cybersecurity and privacy and engineering, in just about everything that was called out within our new academic plan that we just finished last year, that basically doubles down on our commitments to health, security, and sustainability as the grand challenges for this institution, but also adds resilience and entrepreneurship innovation as core areas. And so we've actually started thinking about the law school as a critical hub within the university of the future and how it's going to be connected to each of the other schools and colleges. And that's been seen this year by the creation of the 3 centers, CLIC being the one we're rolling out today. That's very exciting for all of us. But also the joint hires. There is a joint hire between the law school and the Institute for Cybersecurity and Privacy, which is an interesting addition, as well as joint hires in the energy area and law and other areas. So you're gonna see this not just as words, but a real embodiment of how we need the law school integrated. So I'm very pleased that Professors Silby and Matwishin have taken this on. This is a critically important area in law, and it's going to be very important for us given the things that we emphasize in the academic plan here at Northeastern. So Jessica's already talked to you a little bit about the panels we're going to see. I'm sorry to say that I'm booked up heavily all day. I'm not going to get to see these, but they all sound awfully interesting. In particular, the talk by Sarah Zhang, who is the reporter for Vice Motherboard and has articles in The Atlantic and The Guardian, Slate, and Wired, was named by Forbes as one of the 30 under 30 for the category of media. So that should be a fascinating talk over lunchtime. The emphasis on networks is very much a Northeastern perspective. One of our strongest academic organizations here on the campus is the Network Sciences Institute, and we pretty much think of everything here as a network. And the connections that you'll be talking about here today are really what we've based our entire future on, not just your connections, but all the connections that need to be made in the complex society that we're moving forward. We've dedicated our academic plan to educating students who are robot-proof. And that's a networking statement in and of itself, because it means understanding what jobs are going to be taken over by technology, what are going to be left, and what are the special characteristics of human beings that will make them ideal for some of these jobs, and how will they network with teams of robots. We use the word robot very broadly to include any artificial intelligence that's replacing what is traditionally done with natural intelligence. So every one of these network connections is going to run into legal issues, and the legal structure certainly is never designed for something that doesn't exist yet. And as those things keep coming forward, it's a constant conversation between technology and the legal structure. And so I'm really pleased to see that the law school is taking a lead and putting us in the forefront of those thoughts. So congratulations to both Andrea and Jessica on getting this kicked off, and I hope the conference goes very well. Thanks.
Okay. Welcome. Thank you all for being here with us this morning. I'm Andrea Matwishin, a professor here at the law school, and also joined by courtesy in the computer science department. And I am incredibly thrilled to have the privilege of presenting a panel of esteemed people at the forefront of the intersection of health tech, IoT, Internet of Things, Internet policy generally, and the next generation of connected bodies, which is the theme of this particular panel. So undoubtedly, we're all familiar with the Internet of Things, these devices that allow us to remotely spy on our pets when we're away from our homes, or to monitor our yard activity from the comfort of our desk in our office, and to program our DVRs remotely so that we don't miss our favorite episode of Better Call Saul or whatever program we love. The challenges of these kinds of remote, internet-connected and reliant devices, of course, are also multifaceted in terms of the new kinds of risks that they present. So the convenience on one hand is a stellar development for innovation, and on the other hand, we're presented with some new questions around consumer protection and data privacy and information security. And so we're going to talk about some of these issues that have existed in the Internet of Things. They're now moving toward health tech. So the Internet of Things is in the process of transforming itself into an Internet of bodies, where our very physicality of our body will be reliant in many cases in some way on the connectivity that currently we rely on for the Internet of Things. And this is a new iteration of innovation that is already underway. If you look around, Veterans Administration, health programs are at the forefront of some of this experimentation, and other types of health tech that increasingly relies on the internet to provide services for patients. So we'll hear about some of these examples from our panelists, and with that, I will ask each of the panelists to introduce themselves briefly as they present a few comments, but just going down the row from furthest to closest, Frank Pasquale is a professor of law at University of Maryland Francis King Carey School of Law. We next have Gail Slater, who is the general counsel of the Internet Association. The Internet Association is the trade association of the leading internet-first Silicon Valley companies, and has a obviously very policy-rooted and practical perspective on the reality of regulation and where it's moving. We next have Jay Radcliffe, who is one of the most influential health tech connected health devices security researchers in the country, famous for, among other things, breaking his own insulin pump. And he's continued to do great work in that area, making us all safer in terms of our health tech. And next, we have Phoebe Lee, who is a senior lecturer in law from University of Sussex, and has traveled far distances, so we're very grateful for Professor Lee being with us today. And finally, we have a proud Northeastern alum, Gretchen Stubenwall, who is a multiple, is it okay if I say serial general counsel? Sure. Does that work? A serial general counsel working with companies that were tech-driven, in particular, in some cases, health tech-driven. So without further ado, I will turn it over to our panelists, each in turn. We can just go down the row to present some introductory remarks, and then we'll have a few guided questions, and then we'll open it up for discussion to all of you.
Thanks, Andrea. By the way, did my slides, can I use them, or would you like just me to go a little bit briefer?
Your slides are loaded up here, so if you want to swap with me.
If I could just go up there, that'd be great. I could just go through a few. I just have a few images that I think are evocative of what's going on, so I thought I would just use a few slides.
They're on the USB, if you pull them up off of the USB.
Oh, sure, okay. Well, it looks like the Keynote file, the Keynote format has defeated IBM, which I always knew was a risk of taking over a Mac. So anyway, I'll just give a few comments from my own perspective, or just that I think may be just as useful as the slides. So the idea that I really wanted to get across today was an idea of connected bodies and the idea of moving from a credit score to a body score. Okay? And so I've done a lot of work in the past on the idea of credit scores and how they are a measure of individuals in terms of their financial ability, other issues like that. And it's important to realize that the credit score is, well, I'll bring this back to make this a little more aesthetically. Oh, I guess it's maybe we will get them eventually. But it's important to realize that the credit score is really a way of getting people to rank themselves according to some measure of merit. And I see in many areas a similar pressure now in terms of body scores, where they're being introduced, I think, in a very positive way in some contexts, like in healthcare. So, for example, there are accountable care organizations that try to figure out who are the most healthy and least healthy people that are being served by the accountable care organization. But they're also being rolled out by companies that, say, are trying to help advise life insurers and others who might use the scores against individuals, right? And so the question that to me is so interesting here is, to what extent do we want to enable that? To what extent do we think that that's ultimately going to be a positive step forward to enable better health care? Or do we worry that essentially the pressure on individuals to have a body score like their credit score is something that's going to be harmful to them, right? Is something that is going to be used against them. And I think that one of the themes in credit scoring over the past 40 years has been that it needed a lot of regulation to be done well, okay? So part of the regulation came in the form of the Fair Credit Reporting Act for the underlying data, which allowed people to understand and to challenge data that they thought was not reflective of them or was not fair. And I think we're going to need that in any context where we're doing body scores. Another is opt-in. So one of the slides that I wanted to show, but I think I might find it eventually if we want to get into it, is there's a company that recently released facial recognition software that's optimized to tell who is lying about their age, their BMI, their waist size, or their weight. Okay. So if someone puts on their application, I am super healthy, have all these sort of characteristics, et cetera, what this company is saying is that they can look at their face and with facial recognition software tell if they're lying about any of those things, including smoking, too. They say that there's a characteristic smoker's face, et cetera. And what I think is so interesting to compare that to is there's recently a study that was done in China called Inference of Criminality from Facial Recognition. And this inference was a group set up machine learning on a group of 2,000 faces of 2,000 criminals and 2,000 non-criminals. And essentially what they found was they developed a template of 4 criminal type faces and 3 non-criminal type faces off of that. And I think when we look at this type of machine learning out there, it's an example of sort of machine learning being used without an awareness of history, right? Without an awareness of the history of things like phrenology, of the forms of discrimination that can creep into these areas. There was a great article by Megan Rose Dickey in TechCrunch yesterday on algorithmic accountability. All of these things are really critical. So my closing remark would be, as I walked up to the building today, I saw there was a monument, and I can't remember the poem exactly. It was a little patch of doggerel, but it said something like, now it's time for me to give up my books and accomplish real things in the real world. And I was worried a bit by that as a monumental slogan, because I thought, some of the technology that we're rolling out really does need an awareness of history, of law, of sociology, of anthropology. So with that, I hope we can talk more afterward about whether body scores are a way to relate us in ways that will help people understand how healthy or unhealthy they are, or whether they're forms of control that really have to be addressed and minimized and regulated very well. So thank you.
So with that, I invite Gail Slater up to the podium to share her opening thoughts with us.
I don't have any slides. I can just do it from here if you want to.
Sure.
If you want to deal with that. Okay. Hi everyone. Can you hear me? Good. So as Professor Matwishin explained, I'm Gail Slater, and I am the general counsel at an organization known as the Internet Association, which kind of does what it says on the label. We represent 40 internet companies. Our founding members include Google and Amazon and Facebook, the household names. But then we go further down the long tail, and we have many startup companies in our membership. And so with that, I just wanted to thank you all very much for being here today. Thank you to Northeastern. Congratulations on CLIC. One of my great respect for Professor Matwishin, one of my sources of respect for her is that she's fabulous at breaking down silos between corporate and academia, between different disciplines, data security, copyright, and the list goes on. And I think this is a great example of you bringing those values to your job here at the law school. So in my day-to-day work as general counsel, we keep the word general very much at play. And so I'm looking at issues like internet governance, IP, which includes copyright and patents, telecom, and the list goes on. I want to focus on two areas today that may be of interest in this context. One is net neutrality, and the other is what we call patent trolls. And I can unpack both of those in a little bit, but this is just introductory. And then my organizing thought for today is to say, in this context, the Internet of Bodies, we have two scenarios. We don't know how it's going to play out. The first is slightly dystopian and a little scary. And if you saw over the weekend the movie The Circle, you may have gotten a sense of what we're talking about here. So for those of you who haven't seen it, based on a novel by Dave Eggers, slightly dystopian view of the world, and it's based loosely on some of our members, I would say, not naming any names. Emma Watson is the lead character. And there's a scene, just to sort of sum up this dystopian view of this issue, where she goes to see the in-house doctor at the company, and she's given a green smoothie. And without question, she swallows the green smoothie. Now, I'm not a millennial. I would have asked more questions before drinking the green smoothie, I have to admit. It's not really my thing, but she drank it. And next thing she was told, she had a sensor in her body. And they were going to start downloading every scrap of health data from this sensor in her body. So that's one outcome here. It raises a lot of very interesting policy questions. And algorithmic issues are going to be front and center there. And then the other is more of the industry viewpoint, which is this is just another application of the internet. We started with search. We had an information graph back in the day. We organized the world's information online. Then we had the social graph and social media involved. We organized our relationships online. And now we're just going through the next iteration, which is the Internet of Things, possibly the Internet of Bodies. And so that says and suggests that we're in a world where we have existing tools in the toolbox. We have the FTC for data security and privacy. The list goes on, and we have these issues under control. It's for agencies, for regulators to evolve and adapt their existing tools to these new issues. So with that, I'll just park myself and move on to the next speaker.
Jay?
Hello, my name is Jay Radcliffe. I work for a company just down the street here called Rapid7, and I am a security consultant and researcher, which is kind of a polished up name for a hacker. I am kind of one of the first test cases or one of the first areas of research into internet-connected devices, as I am fortunate enough to be a diabetic. And I had an insulin pump, and throughout the course of my work as a computer security person, somebody mentioned to me, you should probably look at the security of your insulin pump and see how it communicates and see if you could do anything with it. And one of the things that I've always been interested in is taking things apart, seeing how they work, and seeing if I can make them do something different. My dad loves to tell this story about how I figured out how a screwdriver worked when I was 3, and I took apart every doorknob in the house because I wanted to find out how these doorknobs worked. How did they keep doors closed, and what else could they do? And he kind of jokes around that I've been doing that with everything I've ever found ever since. So, of course, if you give me an insulin pump, I'm going to take it apart and try and figure out how it works and see what it does. And what I found was really shocking, which was that there wasn't any security surrounding the communication of these devices. And quite simply, I was able to write a program that changed all the therapy settings for this device, and including turning it off remotely, and demonstrated that at a conference, which I thought wouldn't be that big of a deal. Turns out it was quite a big deal. I was thrust into the limelight as being kind of an example, as somebody who has the connected device that they depend on to keep themselves alive, and now there's insecurities. And what do we do about that? How does that play into things? And I looked at it from a technologist perspective, seeing as how that technology works and what the weaknesses and flaws, but also as a patient, as somebody who is a diabetic and is tied to those devices and kind of really needs those devices to stay alive and to stay healthy. Ever since then, I've been doing quite a bit of work in the health field, looking at medical devices, looking at how these devices are communicating with each other, how they're networked together, and also kind of advocating for safety and security measures around these devices. One of the things that I'm quite passionate about is not going to jail for this kind of research. So I worked pretty hard with Andrea and others to make an exemption in the DMCA so that way security research can be done without violating the laws of the DMCA, and to make sure that people and researchers that are good guys like myself can go and do these types of things and help make these devices safer and validate that these devices have security in the forefront of their mind. So even to this day, I still wear connected medical devices, not an insulin pump, but a similar type of device that measures my glucose, my sugar, and it sends it to my cell phone every 5 minutes. So it's constantly reminding me, hey, I had a muffin at breakfast today, and I probably should give myself some more insulin because my sugar is going up. So these devices, I see a huge amount of potential in changing people's lives, especially for kids, for people that have these types of illnesses, to be able to collect that data and to more accurately, take care of their health is an awesome thing. It is also a very scary thing, as these devices are being connected to the internet, are being tied to our cell phones, and I'm sure that none of us here have ever had a problem with our cell phone dropping calls or rebooting on us or having any of those other problems. And now we're going to use them as the foundation to take care of our health, to, monitor our hearts, to monitor other pieces of our body to make sure they're staying healthy and to detect any problems. And that causes some pause. I think that there's great things to come of that, but we have to do that very carefully and very diligently to make sure we have safety in the forefront of our minds. So, thank you.
Thank you, Jay. Phoebe?
So I have slides. Hello, good morning, everybody, and thank you for coming here, and thank you for Andrea for this invitation. And I'm going to talk about my project, which was funded by the UK EPSRC. We carried out this project last year and looking into an array of questions arising from 3D bioprinting. Yes, it is PDF.
Yeah.
Okay.
Yep. Let me just grab the.
Okay. And this, as I just mentioned, this is an interdisciplinary group. We have lawyers and medical sociologists and bioengineers, and we also gather a group of stakeholders to our focus group.
It's an extended screen.
Oh,
Do you need it? You need it here.
okay.
Does that work? Or do you want it here too?
Yes.
You want it here too? Okay.
Yes.
So that's right.
And so we have quite a few affiliations, and this work is also funded by one of the institutions in Taiwan, which is University of Taiwan's Science and Technology. So I've did some interviews and empirical works in China and Taiwan, and looking into different stakeholders' opinion. And today I was just told this this speech needs to be narrowed down to 5 minutes, which is a mission impossible. I'll try to run through the headings. So I'm going to talk about a little bit on the business model of 3D bioprinting. And then I'll touch upon the 2 case studies we have visited, and also looking into a possible embedded watermarking system as a security tool for monitoring the safety of printing and softwares and the printed body part. And then finally, I will look into the regulation currently in the UK, whether this is sufficient or insufficient, and how about the liability of product which has been produced by either medical device companies or hospitals. And I will talk about a little bit of future work. So initially, in my previous work on 3D bioprinting, the patentabilities of human printed products, you have to look into 2 different streams. The first one is in vitro, which is under the current EU or UK law is patentable. But the other one is in vitro, and then it's directly printing of human cells or tissues on the human body. And because we have medical treatment exceptions in patent law, so in this case, the right-hand side of the medical device won't be able to be patentable. And the purpose of my research project is to following on the array of critical issues arising from bioprinting and look into whether we have any possible means to be adopted for anti-counterfeiting, and how do we manage the quality of data and the quality of products, and how do we meet the challenges and mapping the gaps in current legal and regulatory framework. And we also need to map who will be responsible for what, because in terms of bioprinting, we gather around a group of interdisciplinary experts, and then who is going to pay for damages if anything goes wrong. First of all, talking about business model, this is the international or global supply chain of bioprinting. And currently, we have tissues collected from the patient's herself or himself, or we can have all donors' cells, but then we need to send this cell to culture, so which will be developed in the lab. And then every step after culture, we also have to verify the quality of the the cells and products, and then sent back to the patient or sent back to the hospital for implantation. And so under this network, then we have to run a presumption that we might come up with a few regional, local centers for bioprinting. On the one hand, we would like this technology to be decentralized, which is called redistributed manufacturing of bioprinting. On the other hand, we wanted it to be more centralized because it's easier today to do data protection and the monitoring of quality of the products. And we look into two case studies. The first one is ear and nose reconstruction and printing. This primarily is for cosmetics purpose, so it has no literally function. It more serves as a decorational effect on human body. The second one we look into is human trachea. Obviously, we expect this human trachea to be functional so that it could serve and help the patient to breathe and to be able to replace a previous dysfunctional organ. So this trachea is conducted in Swansea University in Wales. And later on, we have a focus group held in King's College London in November last year. And we gather a group of practitioners, clinicians, and regulators, and looking into finding the answers to the possible questions. So here we look into the watermarking system, whether this is a viable means for securing qualities, either in the origin of products, the origin of cells and tissues, and whether it could be sufficiently used to safeguarding the product has been printed correctly according to the code previously written by or designed by a software designer. And thirdly, we would like this product to be traceable after implantation, at least in the European legal framework, it needs to be 30 years of traceability. And second question we look into is whether under the USDMCA equivalent is a section in CDPA is Copyright Design and Patent Acts in the UK, whether this digital management information will be able to serve as a safeguard. But then, looking into this very lengthy legislation, we also struggle here because it seems to suggest that in order to be protected by CMI, the printed product needs to be patentable, copyrightable. But it seems that we have a dichotomy of copyright and patent protection here, because in the UK, if this product is patentable or functional, it belongs to patent, not the copyright. So, for example, if we are printing off a nose or ear, it serves as a functional product, and so this is not an aesthetic product, then it won't be a copyrightable object. Then it will fall outside of the CMI legislation. And I'm going to talk about a little bit on medical product regulation. So here in the EU or the UK, we currently have no specific regulation on bioprinting product because it falls under the ATMP, which is Advanced Therapy Medicinal Products, hospital exceptions. So currently, as long as there is a prescription following from the doctor's discretion, so it won't be able to, it won't need government regulation. Similarly, in the UK, we have the similar special rules. Special rules is basically equivalent to the EU hospital exemption. And the final point I'm going to cover is liability issues. So the products manufacturing by 3D printer will have possible defects. Here are some of them. So as you can see, there might be defect in the original scans, defect in the original designs, defect in the files, or even the 3D printer, or the initial cell or tissues are already problematic. And there are, most importantly, human errors in manipulating this manufacturing process. So we have also looked into the liability issues in either contracts and torts, and further specifically in the UK Consumer Protection Act. We look into whether, to some extent, the hospital, if they adopted bioprinter in their surgery, whether they will need to be held as a producer in this sense and then bear the product street liability, or whether, to what extent, the liability between medical device manufacturer and the surgeons will be defined, and whether there is a clear boundaries between these two. Of course, under this scenario, medical malpractice is still relevant, but in our project, we primarily look into product liability here. So one of the point we look into is whether the medical device company will have like labels designed for like made by Oxford Hospital or made for Oxford Hospital or made for hospital by Cambridge Limited Company. So under these three possible notation, there will be different implications on their legal liabilities. So I'm going to conclude. In this project, we come to initial conclusions that the Internet of Future Bodies, the more important emphasis will be on data control, data management, and data protection and privacy. And the role of data software designer will be very interesting to keep an eye on, because currently the defect in software design is currently not clear whether this will be a product defect or not. And we will also need to keep an eye on whether those kind of medical implementation will be a kind of service or a kind of product delivery. And we also need to differentiate between the different duties and liabilities arising from the production chain, from the software designer to a surgeon. And then we reckon that the nature of healthcare delivery will be very different after adopting the 3D bioprinting into surgery, as the traditional healthcare delivery is more of a craft status. So surgeons, they have more of their creative or their skills, but now it comes to an industrialized, standardized process, and they won't be able to have so much discretion or so much freedom in carry out their surgery. And finally, we are talking about a little bit of the effect of Brexit. So here, again, we are looking, currently we are the UK regulatory framework basically are following the EU ATMP, but then after the Brexit, in 2 years' time, then we will possibly have more freedom to depart from the current regulatory work. So, so this is the details of my project and a couple of articles, and this is my email address, and thank you for your listening.
And last but not least, I turn it over to Gretchen. I'm just going to sit here.
Sure.
Hello, everybody. I'm Gretchen Steubenvall. The time when I went to school here, I was Gretchen Platt, and I graduated 27 years ago. It's nice to be back here. Since that time, I've had a great career in the trenches as a patent attorney and corporate counsel for several, I was general counsel for one internet startup, but I've been involved with the internet industry for a long time because my husband is a serial entrepreneur with the internet, starting back in 1993. So we have lived it. My children have lived it, and it's been fascinating. I'm a mechanical engineer by training and a patent attorney from working in a big firm, small firm, medical products company back in the day where it was called MedRed, and we made medical injectors and MRI equipment. So I was part of the whole patenting team for that company. But my talk today is about what it's really like to be in-house counsel for a startup company. You are in the trenches. There's a lot going on, happens super fast. In particular, the company that I most recently was with, Wowza Media Systems, they were on the bleeding edge, not even the cutting edge of technology, the bleeding edge of video streaming back in 2005. And it started with my husband and his partner wanting to come up with a video blogging system. And the video streaming server that was available on the market didn't work very well. So our tech guy, who lived in Ohio, and at the time we were in San Jose, developed his own video streaming software. And we would test it in our house. We had no content, so our kids would stand in front of that little eyeball video camera and get their stuffed animals out and make little videos. And we would record them remotely in Ohio. That's where it was. And that was a big technical feat, too, because in the time you couldn't record it remotely. You had to record it right where the camera was. And we would hit play, and my husband would have a stopwatch. And we would test the latency with the stopwatch. That was how bad the playback was, right? But we would say, okay, it was 7 seconds. And we'd call the guy in Ohio, and he'd say, okay, wait a minute, give me 5 minutes, and I can fix that. And he'd code, and he'd call back, and he'd say, okay, make another video, and the kids would be up there with their stuffed animals, and we'd hit it, and then all of a sudden the latency would be 4 seconds. And this would go on and on and on in our house. This was in our house. So anyway, yeah, we lived it. Jump forward, we left the whole .com thing. It was crazy back then. We moved everybody to Colorado. And this company, now there's 4 of us. It was my husband, the tech guy, marketing guy, and me. And we were in our house, and we started hiring people, and I had 3 people working on my dining room table, and I kept saying, honey, we really need to move this out of the house. We did. We got an office space in Evergreen, Colorado, and this company has now morphed into one of the largest video streaming companies in the world. We sell into 170 countries. We have 20,000 customers. We can stream anything. We are like the pipe. We take all sorts of video formats, we shove it through the pipe, and we deliver it to the other end. We don't care what we put in, and we don't really care where it goes. That's what we can do. Entertainment, virtual reality, online learning, military, government, space exploration, medical applications. For example, as of 2011, your colonoscopy may have been streamed from the testing area to your doctor's iPhone on the golf course. We were capable of doing that. I wrote the license agreement to do that. Anyway, you're in the trenches, and the law doesn't keep up with technology. We all know that. So what do? Things are happening very fast. You have to rely on the basics. And I can thank Professor Tom Campbell, my property professor, when he said, if you think of property as a ball of string, all these different pieces to it, you can license this part over here, license this part over there, you'll be fine. Well, I've expanded that. I don't have slides, but I have a rubber band ball. And if you can imagine, this is what my job was like. This is your technology. First of all, you have to understand what it is and what it does. And then you have to understand as the attorney, because you're part of the team, right? And your job is to really understand what's in it, not physically so much, but all concepts of the property. So what kind of technology is in here? And how did it get there? Did you hire employees to make this technology? What do their employment agreements look like? They're virtual employees out of the country. Do you have to give them benefits? Okay, that's a weed, right? You don't have to go that far. Did you hire outside help? Was it through a development agreement? Do you have to share the technology that's in here with somebody else? And if you do, what's the confidentiality obligations around that? Who can use what? When, where? For what purpose? You can use it for a rubber ball, but can somebody else use it for something else? What sort of regulatory things are required to be built into this technology? Got to know that. Anything in here patentable? Maybe, maybe not. Did you hire anybody with residual information in their head from a different company? They may or may not be able to use it to put it in there. Did someone come with something? Did they steal it? And they offered it to you and you didn't know, and you built it in here? These are all these things that you have to know what's inside here. That's why we have a colored rubber band ball. So once you're moderately comfortable with, okay, I think I understand what's going on today. Hopefully I understand what was happening yesterday. Today I'm okay, and who knows what tomorrow's going to bring, but today I understand my ball. Now, as a lawyer, it's my job to write the rules or negotiate the rules to move the ball over here without it falling off the table. And I mean that truly, because it does happen. I mean, you'll all learn how to write license agreements, and there's lots of issues, and you can go on and on and on and talk about this problem, that problem. But with high tech, there are some certain things you do really have to think about. We ran into a lot of export problems. Just because you have the technology and it's all secure and you've got encryption and everything in here, you have to get it out of the country. And so what is your export control number? Do the export rules even apply? And I can tell you, I looked at it 1 year, 2 years later, 3 years later. It changes all the time. And the rules are so complicated, you need to have a technical background. I would talk to our engineers and say, explain to me again the encryption, because I'm trying to learn what you're telling me, and I'm trying to put it into the rules. And we go, okay, I think we're okay. We have a number. And then, you try to license to somebody, and they'll say, what's your export control number? And we'll say, well, as of today, it is this, It depends on where it's going, what country. We would go on and on and on about this. And the interesting thing about our software, it was never really delivered. It was downloaded. So we never shipped anything. So we didn't know exactly where it was going. And if we sold it to somebody in Canada, they could really be spoofing from the Netherlands. So with this stuff, you have no idea really where it's going and who you're really selling it to. And I have a really interesting story about that. I have a story about everything. The other thing is you want to think about when you do this, confidentiality and confidential information. As a startup, you don't want anybody's confidential information. You talk to the big guys and they'll say, oh, we need to sign our standard NDA. And you go, big company, yes, I'll sign whatever paper, which is funny because it's not paper anymore, it's electronic stuff, right? But we say, sign the paper. And you're like, oh, they want to talk to us, okay, we'll sign your paper. And then you read it, and you're responsible for all sorts of stuff. And we would say no. As a startup, you have to get confident by saying no. I'm not going to sign that. That's not good for me. I don't want to take on the risk if you bring some junior engineer into some meeting and he starts spouting off about some great idea he has, and now I'm responsible for keeping that quiet. That's not my problem. I don't want that. Be very, very strict about what risk you're willing to take on and not. Talked about the export stuff, the residual stuff, the stuff that floats around in all these engineers' heads. It's very hard you could contract around that, but the bottom line is, the best way to avoid that is when you have a development agreement is no one to say anything. Well, that's not going to work, right? So you have to work with that. Use limitations, you be very specific about what you're letting other people do with your technology. Very specific. And then you say, this isn't going to prevent me from competing with you, and everything else that is not listed, I'm going to be able to do. You have to reserve for yourself, because you don't know what your future activity is going to be. You have no idea, and you don't want to license that away. which I've seen done. So the other thing I would say is, because the law doesn't keep up with the technology, is you rely on your basics. You go back to your rubber band ball, your contract law, corporate law. I mean, stuff I learned first year in law school here. You know, that's when you're in the trenches, that's what you rely on. And I guess that's all I really have to say. I mean, I have lots of stories. I could go on and on about nasty, fun, crazy things that happen, but we can talk about that later.
I'm sure we'll have a chance in Q&A. And so with that, I'm going to throw some directed questions out at the panelists, but I would ask any other panelist to chime in as well if there's something that's relevant to the point that you'd like to add to the discussion. So I'll start with Frank. So Frank, you've done some amazing work on algorithmic transparency with the financial markets. Your book, Black Box Society, is amazing on this point. Could you connect some of those ideas that you have referenced in your prior scholarship to this new area, how some of these dynamics might play out in the context of connected health tech and transparency?
Sure. So I want to have the first tension that I want to know is, sometimes there are people that talk about resistance to the new type of technology, and they sort of, for example, if they're given a Fitbit by the corporate wellness program at their work, they'll put it on their dog, and say, oh, or they'll try to like game the system to say that, oh, actually, you're trying to discipline me, but I can find a way out. And I think it's important to be really careful about, on some level, security is a very important thing. But we also have to wonder, are there certain affordances or slippages of security that we value as a society, right? Because you could always, one of the things that's happening now, for example, in the ankle bracelet industry is, there's this new movement called cheap on crime that says, why do we incarcerate people at $40,000 a year? We can just put ankle bracelets on people, right? But the question then becomes, the second order effects are, do you put on surveillance constantly so that people are like, there's a video camera embedded into their ankle bracelet, and do you add other features to this to make it work better or not? And the same thing has come up over and over again in the credit scoring context, where, for example, there's lots of people who have what are called thin credit files. So there's like 24 million people in America that can't have a FICO score. There are a slew of startups, Lenbuzz, Lendo, I can give you 10 names of startups that say, the way we help these people is we just get more information about them. And I think it's very parallel to sort of the ankle bracelet industry and to some of the other industries. And the one final crystallization of the worries that I have here that I really want to get on the table, and I'm sorry, I should have actually led with this, is I think it's relatively straightforward to think about what, say, a perfect 800 physical health score would be, right? Although we could debate this, and there's actually a meme on Instagram about peak physical performance, about whether this actually is quantifiable or not. But if we think about what would be an 800 credit score, the behavior that certain groups want to see in an 800 credit score is not necessarily the behavior that is best reflective of the well-being of the people scored. So for example, if I am really hard done by a landlord, it's probably in my best interest and the interest of society that I sue in many situations. But if you have on-site as a tenant scoring resource that's going to basically knock your score down for the rest of your life if you're in that file, that's very worrisome. I would say the most worry that I have, given a piece that I have coming out with a philosopher in the journal Biosocieties this year, is the scoring of mental health. Because now, if we move from physical health to credit scores to what's an 800 mental health score? And we have lots of wellness programs out there that are right now asking people 100 set questionnaires, 30 or 40 of the questions are about their mental health, and people's bosses are hiring wellness vendors to ask employees, on a scale of 1 to 10, would you say you are closer than ever to your spouse or not as close? Okay? So we're being sort of enrolled in these efforts to compare ourselves to others by corporate wellness programs. And to me, what we really have to do as we think about transparency here is that transparency is not really a cure-all, because making this system more and more transparent in a way is just in reinforcing its power and making it seem more valid. At some point, you have to sort of push back or say, maybe this just isn't within the competence of corporate managers or others. So,
Would any of the other panelists like to chime in? No? Okay. So let's move on to Gail. So Gail, you referenced in your opening remarks 2 hot-button social policy and legal issues that DC is certainly much embroiled with, and those were net neutrality and patent trolls. So I'd like to ask you to tell us a little bit more about the current dynamics in each of those areas and how you see them connecting to this next generation set of questions relating to the Internet of Bodies.
Sure, thanks. And I will say on the subject of thin credit scores, Frank, I hear you. My mother-in-law, an 80-year-old woman, lives on a ranch in Eastern Oregon. She has one of the thinnest credit scores you've ever seen, but is totally fiscally responsible and fiscally conservative. And her bank keeps sending her application forms to take out yet another credit card in order to build out her credit score. And so I hear you. She's baffled by it. So look, on patent trolls and net neutrality. So these are 2 issues that we see unfolding every day from a policy standpoint in DC, and I'll try to get to their application in this context to the next wave of the internet as best I can, with the caveat that a lot of this is forward-looking by definition. So patent trolls, we call them patent trolls. It's not a very polite term. There are probably IP lawyers, patent lawyers in the audience who take offense at that. So I'll try to be polite and use the correct term, which is patent assertion entities, right? And so just speaking from our standpoint, that's the standpoint of internet companies who are frequently sued by patent assertion entities, and I'll try not to call them trolls. This is essentially a business model for those of you who aren't familiar with it. And so what we say is the patent assertion entity, it's not in the business of making things, of doing things. Their business model is to buy up cheap patents, and the vaguer the better, and to assert those patents in litigation against companies large and small. And so we've seen a wave of this type of litigation for well over a decade now, and the numbers are quite startling. And part of the business model is to sue with a software patent, as I said, a vague software patent, which is why about 70% of PAE activity is in the high-tech sector. In one district, the Eastern District of Texas, and don't ask me how or why that came to pass, but it's a very friendly forum for patent assertion entities. And their business model is such that they thrive down there, right? And so this has been a big issue for my companies for quite some time. From a policy standpoint, we've tried to work with Congress to pass legislation that would tighten pleading standards in cases involving patent trolls, that would lessen the burden on what we call operating companies, so companies that make and do things in litigation versus these patent assertion entities, because the discovery burden in litigation is asymmetrical. The operating companies have a lot of documents, patent assertion entities have none by definition. And so various things that would tighten up and diminish the economic incentives for trolls to litigate in the way that they do. We've not been successful, but then again, a lot of other industries have not been successful in passing legislation through Congress. And so another path that we're working on is filing amicus briefs before the courts. And in particular, one case that recently came before the Supreme Court in TC Heartland. And in that case, there's an effort to have the Supreme Court tighten up the patent venue statutes that would, in a way that would take many of these cases out of the Eastern District of Texas, we think, and move them, spread them across the country in all district courts throughout the land. And we think that would have a good and positive effect on this business model and diminish the incentives for trolls to bring cases. How does it apply here? Well, we'll see. I mean, I think what we've seen is that with every iteration of the internet, there are new software patents, there are design patents granted. If they're strong patents, they will pass muster in litigation. If they're weak patents, though, the chances are they may be bought up by trolls, they may be asserted by trolls. And so there's no reason to think why the financial incentives for trolls in previous iterations of the internet would not also apply in the Internet of Things, the Internet of Bodies context. So that's issue number one. Net neutrality, here we go again. I think you probably all have seen the recent headlines around net neutrality. It's an issue that's, again, it's been around for well over a decade. We thought we had settled the issue, and we finally had some legal certainty in 2015. But boy, were we wrong. And here we go again. We have a new Federal Communications Commission, a new chairman at GPI, who vociferously dissented in 2015 when the Wheeler-Obama FCC voted out net neutrality rules. He says he agrees with the basic principle, which is that all data should be treated equally on the internet, and that all data should be delivered by internet service providers like Comcast, like AT&T, in an equal manner, that there should be no throttling online, there should be no paid prioritization, we'll see about that one, and no blocking of data, subject to reasonable network management. So that's the principle. He says he agrees with the principle. The big political fight and regulatory fight is how do we get to net neutrality? And again, we thought we had settled it in 2015 when the Obama-Wheeler Commission reclassified broadband internet access as a common carrier service. Very politically charged decision, and as I said, Ajit Pai dissented as a commissioner on that vote. And so he's reopened the issue. He is saying, as of last week, that the reason for doing that is the negative impact on internet service providers like Comcast, like AT&T, to invest in their networks as a result of the heavy hand, the regulatory burden of common carriage service obligations. So it impacts their investment in their networks, it impacts their incentives to innovate, is the claim from Ajit Pai. And that's been put out for comment to all stakeholders. The pushback from companies like mine, and we represent startups as well, is that's all fine and well, but as a startup, we support net neutrality. We can't afford to pay for prioritization. We are concerned that our services would be blocked or throttled in favor of those applications being offered by an internet service provider in competition with our services. So that's the basic theory. So we're in for another round of net neutrality, and we'll see how that plays out during the course of the rest of this year. The application here, this is a nascent iteration of the internet, IoT, healthcare, a lot of startups, and a lot of industry consolidation yet to happen. And so I think we have to say that the concern our existing startups companies share, or have, the concerns they have about paid prioritization, about blocking and throttling, would equally apply to even smaller startups. And I think that, speaking for our side of the debate, those concerns are legitimate.
Yeah. When it's your internet pancreas being throttled, the debate looks a little different. So with that, let me ask Jay a question. So Jay, you mentioned the DMCA, the Digital Millennium Copyright Act, and you hinted at your sort of extensive interactions with the law in how that crafts your ability to research and generate new forms of knowledge on security. Can you tell us a little bit about how perhaps some other statutory regimes, such as the Computer Fraud and Abuse Act, have impacted your ability to research connected devices and end-user license agreements? What other kinds of legal experiences have you had as a researcher?
Sure. I think that the best way to go about that is, so when I decided I was going to go take a look at this insulin pump that I was wearing, and I was going to do the research on it, I knew that I was going to get into I knew that I could potentially get into some legal trouble for it. So the first thing I did is to contact the EFF, and I said, I would like a nice pretty box to be drawn around what is safe to research and what is not safe to research. Because it's one of those things where I knew enough to know that once you open the box, you can't put it back in the box. So once I started doing research, if I waded into an area that was kind of gray as far as its legality was concerned, I couldn't undo that research and undo that knowledge. So before I even started, I wanted to have very clear lines drawn. And one of the things that was drawn was a line around reversing the firmware and taking the code out of the device and looking at it. That was pretty clear that you couldn't do that. At the time that I was doing the research, you couldn't do that for cell phones either. You couldn't legally jailbreak your iPhone. So the interesting problem there is that puts bad guys at an advantage. So I only had about 50% of the research ground legally that somebody who was maybe a criminal doing the same type of research, looking to do the same type of thing, there were areas of research that I couldn't do, which was bothersome to me because I kind of felt like I had a disadvantage, that I didn't have all the weapons, I didn't have all of the ground that I could have used to take a look at those. So having only a small portion, looking at the communication between the two devices, was really all I could research safely. And I'm very glad that I did that, because when I did find something, the company that it was against, I think, tried really hard to figure out a way to sue me, to get me to not talk about these types of problems. But because I had done my due diligence and figured out where I could safely do this research, I was pretty confident that I was in a good legal ground. So I'm thankful to the EFF and many of the lawyers that I talked to for giving me good guidance on that, because they were not able to sue me. They weren't really able to threaten me with any kind of lawsuit or cease and desist on any ground because of that. But that ultimately led me to do work with you on making exemptions, so that way there is some balance between being able to do research safely and protect the intellectual property of these companies. The DMCA is designed so that way, as a technologist, I can't go reverse engineer and steal the ideas and the intellectual property of the device. And that isn't the intent at all from a security research perspective. From a security research perspective, I want to take the device apart and learn how it works, so that way I can figure out if there are any flaws. So I can figure out if there are things that might make the device dangerous if put in the wrong hands, or maybe that device can do something different that it wasn't really designed to do at all. An example of that would be like an in-cardio defibrillator that's designed to resync the heart when it beats out of rhythm. Well, if you use that kind of device on a heart that beats in rhythm, it might stop that heart from beating, which would be not really what the intent of that device is to do. So there are lots of different areas where I got lots of questions. So, for example, end user licenses. One of the questions that was asked is, well, when you installed the software for your insulin pump, did you click on the box that said, yes, I accept these licenses? And I said, actually, knowing ahead of time that I was going to do research on this, I said, I did not. You can actually just get that. I got the pieces that I need from that piece of software without actually installing it. So, it's always interesting, when you look at those types of things where they put the sticker, on the CD, so you have to break the sticker open, and when it says you break the sticker open, you're granted a license. There's all these different crafty ways of getting us to agree to these licensing terms. One of the issues that's come up most recently is with tractors. John Deere has really gotten pretty involved in these types of issues with their farming equipment, which I didn't even know was a thing until I found out about it. But the complications of computerizing a farming tractor and allowing farmers to do work on their own tractors, to repair them, but also what are their legal rights to what they could do with their equipment, has become a real big issue. There's arguments that John Deere is making that says that you don't really own the equipment, you're actually just leasing the equipment from them, so you don't have a right to do repair on the equipment or any modifications to the equipment. And cars are starting to become very much the same way, and how computerized they're becoming and how complicated they're becoming. So, those are some of the big areas that I see in, in where the law and the technology or in security are intersecting.
Mm-hmm. And when it's health devices that you perhaps have limited right to repair or test, and your body and your health rely on them, it becomes an even more grievous balancing act between innovation, intellectual property on the one hand, and consumer protection on the other. Thank you. Phoebe, so one of the elements that you mentioned is sort of the complex interaction of different bodies of law and how in practice, in this particular context of 3D printed organs, it starts to become, or body parts, it becomes more complicated. I'm hoping you could tell us a little bit more, especially from the UK perspective, how tracking and tracing of these produced body parts might work or does work, and how recalls might happen, or how the liability cycle could play out in the future. Where do you see it going?
So for the tracking of the origin and the printing process and the products, we use the watermarking embedded system to see, and we have a consultant working on software engineering, and it turns out that actually if it could work, it could, when I talk about the printed object could be copyrightable, and then it could be protected by CMI system. But then there is a whole work of limitation to the watermarking system itself, because at present there's no way to prevent counterfeiting of the watermarking system. So it works well within the whole internal regime, but then if it is counterfeited, that you won't be able to prevent it. And in terms of in my the report, the EPSRC report, which I identified in the last page of the slides, we talk about more on the limitation to the watermarking system, and we also think this is very relevant to blockchain technology, and then moving on to liability issues. The current legal landscape in Europe or in the UK is the hospital is basically treated as a service provider, so it's currently exempted from product liabilities. However, if the organ is printed at the theater and during the process of a surgery or implantation, then the doctor or the hospital themselves will be deemed as the producer, which will be put them in a very precarious position of being a product manufacturer, and they will be possible to be liable to Consumer Protection Act. So currently, if the law stands as it is now, then the current business model will be hospital will oppose to adopt printing process in the surgery system. So this will lead to the medical device company to out licensing their skills or their infrastructure to the hospitals, such as our photocopier now we use at the university. Our office is basically owned by the photocopier company, and the maintenance maintained by them, and any liability arising possibly will distribute to them. So, but then whether this kind of business model is satisfactory, and we still don't know. And if we want to encourage hospital or surgeons to embrace this technology, we will need to safeguard their position, whether they could still stand in a safe position to carry out medical service, and according to their expertise or their judgment, but not to industrialize of manufacturing of printing process. So I think this is the law or regulators need to come in to have a say.
Thank you. And our final question before we open it up to all of you. So Gretchen, one of the interesting points that you made related to concerns over latency of transmission of content. How do you see the latency concern playing out in something like a health tech context when it's a medical device attached?
Yeah, so back then when we were doing it, latency was a problem. And that was, do you remember the progressive download? You watch the bar and then you would see. That's not how it's done anymore. You rarely see that. It's all streaming. And we were streaming the video when we could time it with a stopwatch, but now it's not that we don't have that kind of problem anymore. It's basically real time. Like the average person, the doctor who's doing it probably wouldn't notice the slight latency in it. And we continue to try to make it even better. We want higher resolution and lower latency. And I know a lot of these problems are solved technologically, not legally, because we have to go too fast. And like the piracy stuff, the export stuff, you can bake software into your product so it doesn't intentionally go where it shouldn't go. So that's the other thing I would say. There are a lot of regulatory and legal issues, but technology can solve a good part of it too.
And on that note, let's open it up to questions both from the panelists for each other, and we'll give you first crack if there are any, and we also invite all of you in the audience to ask questions. And if the internet audience wants to send in questions, please DM or tweet at NUSLCLIC, and we will funnel your questions to our panelists. Jessica.
So thanks, this was a fascinating panel. So one of the first questions I have is just about the role of trademarks or labeling law in whether it's surveillance issues about your biometrics, or it's the body part, or it's about the information that's coming through the stream. I guess I'm wondering what role source designation and who's in control plays in the risk management feature of these products. So, the product is made, you had a label, Phoebe, it's made by, made for, or made for by. Those are the three choices you had. And I'm just wondering what you all think, will those kind of labels solve some of the problems that any of you are identifying in the relationship between the audience and consumer and the maker of these things?
I can speak to that. As a startup, you have a trademark, you want to promote that, but you push all the risk off. Now, we're just video. I mean, it could be applied to anything. We're not body parts or the insulin pump, but that's how we got around it. You just deflect risk. You buy the amount of insurance you can possibly afford, and then you just deflect it. I know that's not the answer you wanted to hear, but that's what startups do.
I can imagine a doctor getting information from a colonoscopy on a screen and the screen saying, this image is provided by...
Powered by Wowza is what we always
right,
say.
Powered by. The question of sort of how accurate that pixelation is and what they see. I'm not sure that the trademark does that for you.
It doesn't. It's just the label.
Yeah.
Yes.
Hi, I'm Katrina Fitzgerald with the Electronic Privacy Information Center, EPIC, and I'm a proud Northeastern Law alum. And Frank is a very valuable member of our board of directors, so I wanted to ask Frank. Algorithmic transparency obviously is a huge issue in so many portions of our society. Great article in the New York Times today about its use in criminal justice systems. But to tie back to this panel, where do you see electronic health records going? I have a 3-year-old. Every stored in her electronic health record. What's our future in terms of algorithms being used to process that data? Is that going to be used in health insurance decisions in the future, do you think? And if so, what are policy frameworks we need to start thinking about to prevent that or to ensure it's used properly? Like, is transparency enough for
Yeah.
to properly prevent that?
Can you repeat the question for those who are, but the audience is not being picked up?
Sure, the
Oh,
question,
sure.
do you want to repeat it or do you
Oh, no,
want?
if you could, yeah.
So
Yeah,
in brief, the question was, how do we create regulatory or policy paradigms? Are there good ones out there to deal with the next generation of health records, digitization, and the types of connected issues that we've been talking about on the panel?
Yeah, so I thank you so much for the question, Katrina, and I really think that the one bottom line for me is, as someone that talks a lot to people that try to do really good research on health records within the healthcare system, is to be more open and accepting of the research that's proposed by people within the healthcare system in terms of how they want to use some big data and other means to try to improve. For example, I was talking to somebody who does machine learning on Facebook posts to figure out new drug-drug interactions. Right, and there are some skeptics among the traditional medical community that say, "Oh, this data looks pretty bad," but on the other hand, the people that are doing machine learning are really excited about that. And so, I think to the extent it's being used for those purposes, I think it's very positive. I think, though, that when we open it up to some of these other financial, educational, real estate, so many other contexts, that's where we need a much more restrictive framework of regulation on the use of both the data and the inferences, right? For two reasons. One being, nobody is going to opt into a system of the type of 360 surveillance and understanding of your life patterns, your health records, how they connect to your financial records, how they connect to other records. No one's really going to want to opt into that if they are constantly being bombarded with reminders that it could be used against them at any time, like, say, their next job interview or something like that, right? But given a robust enough framework of protections, which I think the European Union is moving toward in terms of the General Data Protection Regulation, the GDPR, if you had commitment to something like that in the US, that I think would smooth our way toward the more positive, beneficial data uses and away from the type of stratification, exclusion, stigmatization that is behind a lot of the more negative uses. So that's a broad level way. If I had to give a very concrete thing I would want tomorrow from the Federal Trade Commission, it would be an absolute rock solid commitment that any company using with data has to have some record of the provenance, where it comes from, and has to keep a record of where it's going to and the destinations. Because without that, we're in a data Wild West that is not merely a threat to scientific integrity, but also to everyone's privacy. Thanks.
Yes.
So I'm Brooke Baker. I'm a faculty member at the law school, and I've worked for 20 years on access to medicine in developing countries. And so I'm interested in this panel, in particular, to learn what you're thinking about to solve the problem of the exclusivities that can restrict access for poor people in poor countries, and then also prevent the follow-on innovation to adapt technologies to use in resource-poor settings. So I guess the question is, in the work you do, what do you see as some of the limitations and exceptions that exist? Were there gaps in such exceptions and limitations in regimes that currently apply? And even in the licensing context, where the need for regulation could be quite intense to try to prevent new forms of perpetuations of exclusivity. So I'm very interested to hear what your thoughts are about how to deal with more of the access side of the problem, and particularly where exclusivities and high pricing can leave lots of people without access to these new exciting medical technologies.
So the question was about access to new medical technologies in developing countries and how exclusivity of rights and other types of legal mechanisms play in, and whether any of the panelists have run into those issues in their particular research.
Thank you for your question. And I wrote a paper in 2014 also talk about these issues, the ethical issues of access and benefit sharing for this technology. And obviously, following on the current patent regime, you could imagine in the future a kidney or a heart may cost up to like $30,000 or more. So basically, the technology is, in reality, it's accessible, but then the price is inaccessible. So, but in one of my slides talking about the current European or UK regime is that we have a medical treatment exception. So, following on this framework, those products that is printed in vitro, so in a lab, will be able to receive patent. So, which is, you can imagine, it has a higher premium to a higher price, and those printer that directly apply printing product on the human body, they won't be able to be patentable. So you can imagine the product will be cheaper than those printed in lab. So currently we have this kind of two pillars of patent implication, but we will also need to follow on the access to medicine dilemma, that whether the health impact fund will be applicable. So in the future, we need to fund this kind of innovation, not only by the pharmaceutical companies or medical device companies themselves, where they can determine the price of the product, but we need to sponsor the innovation of this kind of technologies by their impact to the society, their impact to health. So this is one of the proposals that I could come up for.
Frank, did you have follow-up comments?
Oh, did you have
Gretchen, did you have follow-up?
From a video perspective, online learning and distance learning, remote medicine has been around for a while, and people out in remote areas can actually look on their cell phones and have interactions with doctors all over the world. So it's not actually delivering a product, but you can certainly educate healthcare providers out in these remote areas how to do something. So in that regard, I think I would like to think it's pretty accessible and not that expensive anymore to do that.
And I just had a very broad response, which was that in the 2000s, I did a few articles on this problem, and I thought then and think now, it is such a critical issue, and one of them was called Access to Medicine in an Era of Fractal Inequality. And I looked at like the Health Impact Fund that Phoebe mentioned, and some other like Jamie Love's work, which I think is very important work in terms of trying to tailor world intellectual property organizations to allow access to those who don't have the resources that are prevalent in the developing world, in the developed world. But in the 2010s, one of my focuses has been on ensuring that the health sector gets a share of GDP that is commensurate with a recognition of the value of the work done by researchers, doctors, hospitals, and providers, and ensures future innovation. And I think this is really interesting, and I think that one of the tensions that's going to be facing the future of both the health and education sector is if we buy into the Baumol-Cowles disease story too much, of these sectors being a drag on our economy, we unfortunately might take away resources that could be used to really make things better in the future. And I think that's where like Terry Fisher and Tala Syed's work is particularly insightful here in terms of trying to figure out ways of getting resources into the system. And so I just think that part of it is that yes, we have to change world intellectual property rules, but I think there's also got to be a way of, as inequality accelerates, particularly in some of the developing countries, a way of developing sustainable taxation to pay a fair share towards innovation is important too, among the people that can pay in those places. But, yeah.
Okay. Since we started a little bit late, I will indulge in one short question. Is there a short query from the audience? Please.
I just had a question, I guess, applying to the CLIC sector, people getting intervention for therapy. What is the view of the patient in some of the comments made? A lot of times you split between the patient and the consumer, and the sense that there's a very autonomous, proactive person. I'm just interested in any comments about what do we expect from patients that are receiving these technologies, and is it different now, will it be different in the future?
Well, I think you've raised an important question on how we conceptualize the role of the patient in their own care, and whether the traditional paradigms from consumer protection that have worked for us in other more traditional, less connected contexts, whether they can be transferred directly into this one. And that's certainly something that our paradigms should be sensitive to as we're constructing them, because it's not clear that they do transfer directly when it's physical integrity, bodily integrity, and dignity on the line as it interacts with the internet. Things become a little more murky, and you have innovation concerns on the one hand, but you could have, unfortunately, a lot of physically harmed or even dead consumers/patients on the other, and the blue screen of death can really become a blue screen of death. And with that happy thought, we'll conclude our panel. Thank you.